Hello dear friends, today in continuation with the art of problem solving series, I have brought to you a question on complex numbers from KVPY examination. So Z is a complex number and we have been given this particular equation and we need to find the value of S in which interval it lies. Okay, so before proceeding we should have a glimpse on this particular equation. This particular equation is of degree 8 and it cannot be solved easily by some simple methods or techniques. Apart from that, there are terms containing Z as well as I times of Z. So the first step should be to club them together and give them a single variable type of form. So I can write this equation like this: 11 I times of Z to the power 8 minus 20 I times of Z to the power 7 plus 10 into I times of Z minus 22 is equal to 0. Let us say I times of Z is equal to W. Then this equation reduces to 11 W to the power 8 minus 20 W to the power 7 plus 10 W minus 22 is equal to 0. Okay. Now we can see some similarities or some symmetry here. 11 W to the power 8 and 10 times of W, 20 W to the power 7 and 22. Here if we take 2 common, then it becomes 10 and it becomes 11, which are present already here. So if I take W common and write the equation like this: 11 W to the power 7 plus 10 is equal to twice of 10 times of W to the power 7 plus 11. Now see, I want to discuss something ahead of this course at particular point of time. W by 2 is equal to 11 10 W to the power 7 plus 11 divided by 11 W to the power 7 plus 10. This can be written as T of W, right? And this particular fraction can be written as something like that: AW plus B and CW plus D, like this. So AW naught, we can write W to the power 7 something as beta, then A beta plus C, A beta plus D, like this. So actually, while you will be taught in your degree classes that this particular transformation is known as fractional linear transformation, FLT, or Mobius transformations. And under that transformation there is an inverse transformation, and if we adopt that particular method here, then this question will get solved very systematically. I am not saying very easily, because what we are going to do through that particular thing under Mobius transformation, the same thing we are going to do here without any that particular name. So one thing is very clear, that the question setters might have this particular thing in their mind, FLT, while setting this particular question. Okay, so let us move ahead. On the steps to solve this question. So what we can write from here? From here we can write if I square both the sides. Okay, why I am squaring both the sides? Because I will get some term common and they will get cancelled out. So let us square 121 W to the power 14 plus 100 plus 110 W to the power 7 plus 110 W bar to the power 7, right? This is on the left hand side, and on the right hand side it is 400 W to the power 14 plus 121 plus 110 W to the power 7 and plus 110 W bar to the power 7. Okay, From here we can see that some terms will get cancelled out. And what are these terms? From here we can say, before doing this, let us analyze this equation a bit more. See, these 4 terms, w square and this particular term and this, they all are positive terms. So what if I have something like this, 4, 5, 5 into 4 and 4 into 5, okay, they are equal. Let us say this is A, let us say this is B, C and D, okay. Now if A is less than C, A is less than not, A is greater than C, here in this case A is greater than C, this implies that B is less than D, okay, because they are positive numbers. And if it would have been like this, 4 into 5 is equal to 5 into 4. So see here, if it is A, B and C and D, so here A is less than C, then this means that B is greater than D, okay. So we will use this particular concept here, and let us say if mode of W is greater than 2, the square root of 4, okay, mode of W is greater than 2. So what we can say about these particular terms? That means this particular term should be less than this particular term. So we can write it here like 121 W to the power 14 plus 100 is less than, I am cancelling these two terms because they are same here. So 100 to the power 100 into W to the power 14 plus 121. So from here we can write 21 W to the power 14 is less than, we can one more thing we can write here is if we take W is greater than equal to 2, then also we do not lose any generality here. So we can write it 21 W to the power 4 is less than 21, and this implies that W to the power 14 is less than 1, okay. This implies that W is less than 1. This implies that W is less than 1. And one more thing we can write here, if we are taking here greater than equal to, then we are free to choose greater than equal, less than equal to here 2, okay, here 2 we can put it. Why? Because it may be a condition, no, when A and B are equal and C and D are equal. So incorporating that particular thing here, we can install the equality sign. So W is less than equal to 1. Now we will be analyzing this particular result that we got. What we got? We took the condition that if mod of W is greater than equal to 2, then if mod of W is greater than equal to 2, then we can write that mod of W is less than equal to 1, right? Yeah, because here now while squaring we can put mod of W to the power 14, it would be correct. We can't write without modulus. Mod of W to the power 14, I left it by mistake. So mod of W is less than equal to 1, right? Now these two statements are contradictory, right? Because one is saying that W is greater than equal to 2 and another is saying W is less than equal to 1. Is it possible simultaneously? No. Simultaneously these two statements can't hold, and so these two statements are false. So if we take another condition like the condition that we took here, W is greater than equal to 2, and if we take a condition if mod of W is less than 2, then corresponding to it the condition that we will get upon solving this particular equation would be mod of W is greater than 1, okay. So this particular condition both of them can simultaneously satisfy, and therefore in this particular question mod of W should be greater than 1 and should be less than 2, should be greater than 1 and should be less than 2. Now what we were intended to find out actually in the question. The question had asked to find the value of s, and it was mod of z square plus mod of z plus 1. And earlier what we had supposed, instead of w, we had actually supposed iz equal to w, and also we had concluded that mod of z is equal to mod of w. Therefore, in place of mod z, we can put a value of 1 to get the lower bound. So if I put the value of 1 here, then s lower bound is equal to 1 plus 1 plus 1 3, and s upper bound is equal to, we will put the value of 2. So 4 plus 2 plus 1, that is equal to 7. So s lies in the interval, s belongs to, or we can write like this, s is greater than 3 and less than 7. Okay, so this question gets solved like this. If you have any doubts, any queries, please do feel free to ask in the comment section, and do not forget to like, share and subscribe this video. Thanks a lot.